Hello everyone, and welcome back to Reverse Engineering Linux 32-bit Applications. In this video, we are going to continue our discussion of reversing malware, and in particular, we're going to have a look at ELF files. So we are continuing to get a little bit lower down in our analysis. So far, we've talked about just some general tools that you can use in order to get a vague understanding of what something might be trying to accomplish. What kind of functions does it load, and what sort of symbols does it have, things like that. So now I want to talk about ELF. So what is an ELF file? An ELF file is an executable and linkable format file. Now, a lot of people might think this stands for executable Linux file, and that's not actually correct. This is a file format that is used in many Unix-like systems. It's not just for Linux. This is the standard format for executables, sure enough, but also for libraries and for object files. Now, when I look at an ELF file, it has two different views. It's the way that I look at it when I'm executing it. That's the one view, the executing view. And the other view is the linking view. This is how I will look at this file if I'm using it to link together an executable. Now, if I'm looking at it from the executing view, my file is broken up into segments. We'll talk more about this in a little bit. If, on the other hand, I'm looking at it from the linking view, my file is broken up into sections. For the most part, sections are normally a part of a segment. So a section is usually a subsegment, if you will. There might be some exceptions to that, but that's generally speaking what we have. So here we have kind of the high-level view of our ELF file. So the ELF file begins with an ELF header, and then that is followed by a program header table. So if you look here on the right, you'll notice that the execution view needs this program header table. So it is possible to have an ELF file that doesn't have all of this stuff, but this is just kind of how the specification works. So we have a program header, and this table describes the segments. So these are these larger chunks, if you will. At the end of an ELF file, you will have a section header table. The section header table is optional in the execution view. And then if I have the linking view, I'm trying to create an executable. The program header is optional in this view. Doesn't really need to be there. It's not used at all. Instead, what's not optional is this section header table here at the bottom. And again, what does that do? It describes sections. So these are the smaller chunks that are being described here. These are the smaller chunks that I need in order to link together a program. And you might say, well, why would you have both of these in the same file. Believe it or not, you could have a file that both can be run and can export some functions, etc. So the specification for an ELF file allows for all of this to happen. So let's have a look at an actual ELF file. So I'm going to go ahead and bring up a terminal. And I had created a couple of executables. Here they are. Bind shell and reverse shell. So I'm going to use a tool called rev036. rev036 allows me to read an ELF file. I'm going to start by doing the standard thing. I'm going to say, I don't know how to use it. rev036 help. When I do this, you'll see that I have the option to show different items. So the first item that we'll look at is the file header. So this is the header for the actual file itself. We can also look at the program headers and the section headers. With all of these, I have an option, the -W option, that allows me to have an output width that exceeds 80 characters. This will show me a little bit more information and a better display. So before I do this, let me just go ahead and bring up one of these files in hex edit. And notice how this starts. This will start with the value of 7F followed by ELF, ELF, and some other values as well. So this is the standard file signature. The 7F is something we call a magic number. So a magic number is in the first byte of a file, and it says, hey, this is what I am. And there's an additional signature there as well. Now, of course, if I look, I will see some strings, like this one here. It's referring to a library, and some other things as well. So this tool will allow me to look in to my file. I'm just using a hex editor here because I wanted to show you the very beginning. Now if I use read-elf instead, I can say file header, and I would like to read the file header -W, capital W, that is, wide format on Xingqi bind shell. And it tells me about it. It says, here's the header, 7F, ELF, and then some other values. It is a ELF 64. That means that it is 64-bit. It is 2 complements, little ending. This is how it does negative numbers, 2's complements. That's pretty standard. Little indent, also very common. Version 1. This is for Unix System 5. That is the branch of Unix that Linux comes from. ABI version type. It's an executable file. It is made for an AMD 64-bit processor. Version 1. Here's the entry point address. So this is where the program execution begins. Start of the program headers is at 64 bytes in. Start of the section headers, this is at the end of the file, 12,784. Any flags, size of this header, size of the program headers, number of program headers, size of the section headers, number of section headers, and the section header string table index. So this is giving me a little bit more information. So let's start by looking at the program headers. These are the ones, recall, that are pertinent to the executable view. So I will just change this from file header to program headers. And there you have it. It tells me it's an executable file. There are 9 program headers starting at offset 64. So here they are. Here's the type, offset, virtual address, physical address, file size, mem size, any flags. So flags will be readable, writable, executable, any alignment. So often we want to align things on certain byte boundaries, and this is just giving us a clue. This is saying this is approximately where we need to load this stuff. So we have P header, my program headers. I have enter P, requesting program interpreter. So this is the linker, if you will, that I'm using. And the next section is my program itself. It starts at the standard place, 4000000. It is readable and executable. We talked about the importance of this. It shouldn't be readable, writable, and executable. I have another segment right here that's readable and writable. Here's my offset into my address space, and here's my offset into my file. Another segment that's dynamic, different boundary rules. A note. A note is just exactly what it sounds like. It is there in order for me to have any notes on my program. I'd say, well, what kind of notes? You could look into this and see what kind of notes it's going to give you. It's really pertinent to, how did this thing get built and those sorts of things. It's not like somebody's diary that you're going to find in here. We have a couple of segments that relate to my compiler. EH frame, error handling frame, my stack. Notice my stack doesn't have any address assigned because it's created dynamically. relocatable, read-only. Here I'm going to have a read-only segment. So once this has been loaded in memory, you can't change it. So any program constants and things like that might be located there. And then here I have my section to segment mapping. So I have my section 0, segment 0, segment 1 maps to enter P. Segment 2 has a whole bunch of stuff in it. So enter P, note, ABI tag, note this, GNU hash, dyn sim, dyn stir, and a few other items. 3 is mapped to these sections. I have my dynamic segment. So that is also mapped. So I have 0, 1, 2, 3, 4. It's mapped to this guy. I have my note. And then I have my error handling frame. My stack. And here I have these sections. Init array, fini array, JCR, dynamic, and .got. So those are my segments. And again, that comes from that program headers at the start. What about the other thing at the end? Let's have a look at that. So now instead of program headers, I want section headers. And here I got a bit more information. It says there are 31 section headers starting at this offset. What's the section? Section 0 doesn't have a name. It's a null type. And it doesn't have anything terribly interesting here. Section 1, enter P, type prog bits. Where does it start? How big is it? I have my notes. I have 2 of them right here. And you'll notice that I have flags. If I scroll down to the bottom, it says what are the key to the flags. A means allocated. I'll see quite a few of those. X means executable. I might also see merged and strings. Notice that if I look here at my comment, I have merged and strings. W, writable, A, allocated. So again, I shouldn't see something that is writable and executable, which I don't. So here are my different sections. We've seen some of these before, things like the text section. This is the actual program itself. We will see a number of sections such as data. This is writable and accessible. Writable and allocated. We have BSS, another guy that stores data. And we'll see a few other kinds of sections as well. So this is a section header table. So quick recap, if I look at an ELF file, I can look at it from a program view and executing view, in which case I will look at my program headers. And here are some program headers for this particular executable. If I look at it from a linking view, then I want to look at the section headers, which are found at the end of the file. And here's a list of the sections in this particular file. So we will delve down a little bit more deeply into some of these sections and segments in future videos. For now, I just wanted to kind of introduce this topic here. And that is pretty much all I had to cover in this video. Again, this is one video in a whole family of videos that we have here at Pentester Academy, your source for everything InfoSec. And I look forward to seeing you in this course or another course soon. See you then.